Okay, so this example, this is another differential equation. So notice we have the dy dx, and they're giving you the initial condition. So first thing I'm going to do is I'm going to separate the variables. Okay, so remember these problems are worth 6 points, just usually this part. And I'm going to explain to you how we pick up points along the way. So even if you can't get all the way to the end and finish the problem, you'll be surprised by how many points you could pick up. So I'm going to separate the variables, and just separating the variables, I cross multiply, and I end up having to move this y term over. So that's kind of the step that's missing here. So I'm going to put dy is equal to 3x squared y dx. And then I move this y over by division. So I kind of skipped that step here. So separating the variables, that's already 1 point. Okay, then I'm going to take the antiderivative of both sides. So on the right side, that's just reverse power rule. On the left side, I hope you recognize that since I have just a constant on the top, which is 1, it could be anything. It could be 2, it could be 3, it doesn't matter. The point is that there's no variable y here, it's just dy. And I have y to the first power as opposed to y to the second, or y to the third, or y to the half, or y to the negative 2. I have y to the first. So you should recognize that that is ln. And just getting this antiderivative on the right gives you 1 point. Getting this antiderivative on the left gives you another point. Okay, and then it says in the scoring guidelines that you get a point for the constant of integration. So I think that just means just putting the plus c, to be honest, because you get another point for using the initial condition. So this has to be where that other point comes from. So notice that right now I've racked up 4 out of the 6 points that this is typically worth on the free response. Now I need to use my initial condition. So using my initial condition to get C gets me another point. Okay, so I'm going to finish this up right here. You know, the natural log of 1, I mean, it's the absolute value of 1, which is still the natural log of 1, is 0. And then 2 cubed is 8, not 6. Okay, so I have 0 is equal to 8 plus C. You move the 8 over, and C is negative 8. So that's my 5th point right there, using that initial condition and solving for C. Okay, so if I'm going to get the final point out of the 6 points, okay, I'm going to have to get y by itself. Okay, so now I'm going to go back to where I was here. Okay, ln of the absolute value y is equal to x cubed minus 8. So, you know, for an exponential, for a natural log equation, okay, this is an absolute value equation, the only way I'm going to get the y out of there is to rewrite it as an exponential. So I'm going to lift and shift. Remember, base of natural log is e, and these two swap sides. Okay, so it's y equals plus or minus, because it's an absolute value equation. Okay, if I say the absolute value of x is equal to 3, you have 2 equations. It's a piecewise. X is equal to positive 3 or x is equal to negative 3. So that's precisely what I'm doing here. Okay, so I have plus or minus e to the x cubed minus 8. So I have to determine, well, which is it that I get to keep? And that's where my initial condition comes into play. So I'm going to double check my initial condition to know which one I'm going to plug in. Okay, so I don't want you to generalize and assume that you're always going to keep the positive version just because this is here, because sometimes they got some tricks up their sleeves. So I'm just going to plug in the one for y here, and I have plus or minus e to the 2 cubed minus 8. So I got 1 is equal to plus or minus e to the 0. And remember, e to the 0 is 1. So if I want positive 1 here, I'm going to have to keep that one. Okay, so then my final answer is I keep the positive version, e to the x cubed minus 8.